Example 3.15. We want to find the optimum value of each of the following quadratic functions. So that means we want to find the maximum or the minimum value of y and the corresponding value of x. So let's try to complete the square. So let's rewrite the quadratic function. So it's in this form: y equals a times x minus h squared plus k. So we can find the maximum or minimum value of y as well as the corresponding value of x. So let's get started. We look at the first two terms and we focus on the coefficient of x, which is positive 6. So I'm going to add 6 over 2 squared minus 6 over 2 squared. So I'm adding the same constant, so that's why I have not changed the quadratic function. Our next step is perhaps let me try to rewrite this a little bit. So I have x squared plus 6x. This would be my 3 squared minus 3 squared minus 7. So we can focus on these three terms, the first three terms, which would give me a perfect square of x plus 3 all squared. The last two terms will be negative 9 minus 7, which would be negative 16. How do we get x plus 3 all squared? So this x comes from here. Because we have plus 6x, so that's why this is positive. We follow the same sign. And 3 inside the bracket comes from this one. And where is the square? The square comes from here. So I get the perfect square of x plus 3 all squared. And at the very end, I have negative 16, which comes from the two constant terms at the very end, minus 3 squared minus 7. So we are ready to find the optimum value of y. Do I know whether it's max or mean? I have to go back to look at the coefficient of x squared. The graph of the quadratic function is opening upwards, so that means we get a minimum value of y, which is negative 16. And when that happens, when x equals negative 3. Why do we have x equals negative 3? We look at the perfect square, x plus 3 all squared. So x plus 3 equals 0, so we get x equals negative 3. So we have got the optimum value of y, which is negative 16, and is a mean value. And the corresponding value of x is negative 3.